Hello, Spencer. So, what we're going to do is we're going to walk through how to do these problems. I'll also talk about how to do the graph, and then we'll go from there. So, this particular problem, this type of problem, I'm going to do up to right over here. I'm going to do everything before that line. The reason why is because once you kind of see how to do each type of one, I think you should be able to do the rest of them relatively easily. So what you're doing in this first page is just writing out equations and then balancing it. You probably don't even need anything except for the chemistry reference table. You probably don't need table N, you don't need table O, because you'll have the notations for each of them once, I get done writing it. But just as a little key for you, I'm just going to write the notations up here. So your alpha is 4 over 2 HE, so this is your alpha. Your beta, again, you can choose either one of the notations on table B, but I'm just going to choose the letter B for today. 0 over -1 beta. There are no positron decays, there's only gamma. So gamma is equal to 0, 0, and the gamma symbol. Okay. So now that you got your symbols down, let's get into it. So you might notice already that with every equation that's done, this last element that you find, let me actually make that a little bit more transparent so you could see it. I apologize. So this element that you find gets moved down here. So it's kind of like a moving process. So when I do this, I'm going to do like certain colors. You might see me highlight things in certain colors. It's kind of what I'm doing. So anyway, let's get into that. So the first one says that we are doing a beta gamma decay. So what we're doing for that is first we're going to write out that TH I highlighted. So that would be 234 90 TH. Then we just draw an arrow. For all of these, as soon as you write down the first element, you just draw an arrow automatically. And that's telling you, again, beta and gamma. So we're going to draw the beta notation, which we said was 0 over -1b. Plus your gamma notation, which is 0 over 0 gamma. And now we have to balance the equation. So I'm going to show you the work below, but I'm going to erase it once we're done because we're going to need the space. So again, first we look at mass. We want to make sure that they have an equal mass and an equal atomic number. So we have 234 is equal to 0 plus 0. So what would the mass be? 234. So we know our mass for our unknown is going to be 234. For our atomic number, we have 90 is equal to -1 plus 0 plus x. What would x have to be when solving this? It would have to be 91. So the top value, again, 91. And which element is element 91? We're going to look at our periodic table. I'm just going to pull it up on our chemistry classroom. Okay, so element 91, excuse me, I just woke up, is Pa. So our element is Pa. So now we're taking this 234 91 Pa and we're going to move it down here. So notice how I just moved it right down, because that's what you're going to be doing for each one of these problems. You're going to write out the equation, move down to the conclusion, and then you're going to keep going until you get to the end. So let's keep going. So now we're going to start off again with 234, 91, PA, draw an arrow automatically, and again you see that we have a beta and gamma decay. So we're going to do that. Again, we'll draw our beta symbol, 0, -1, beta, plus 0, 0, gamma, plus. Now again, it's just a matter of balancing the equation. So I'll write down the stuff again so you can see how to do this. By the way, for all the work that I'm doing, if you want to do it for each of the problems, that's totally fine. I would just say do it on a separate sheet of paper. So again, we bring down our little plus signs. So we have our mass is 234, 0, 0. So what would x have to be? It would have to be 234 again. So I'll write that in black. And then we've got 91 is equal to -1 plus 0 plus x. So what would x have to be? It'd have to be element 92. And which element is element 92? If we take a look, we see it is U for uranium. So we put the letter U. And again, we are taking what I'm highlighting as yellow, and we're moving it right down over here. Again, that is 234, 92 uranium. So basically you can see what we're doing is we're doing kind of like a big zigzag when solving these problems. So let's try the next one. So the next one's different. It's an alpha problem. Notice how I'm going to highlight it red. So for your alpha decay, all you need is an alpha particle. So first you start off with your first element, which is the 234, 92 uranium. You draw an arrow. Then you draw your alpha particle, which you can see I wrote up here as 4/2 He. Plus. Now it's a matter of balancing the equation. So let's balance it. Bring down our plus and equal sign. We've got 234 as our mass. So far we have 4. What would x have to be? It would have to be 230. And for our other one, we have 92 is equal to 2 plus x. What would x have to be this time? 90. And which element is element number 90? We take a look at our periodic table, and we see that it is TH. So we write that down, TH. And again, what we're going to do is we are going to put this, we're going to set this equal, we're going to move our TH, our 230/90 TH, and we're going to move it down over here. Notice how I'm highlighting everything green so you can see the pattern. So now again, now we have a different decay. We have an alpha gamma decay. So I'm going to do this last one with you. So again, we start off with our 230/90 TH. Draw an arrow. Then we're going to draw our alpha symbol, 4/2 He. But now we see there's also a gamma involved. So we're going to draw our gamma symbol as well. 0, 0, gamma. Plus, and now we need to find what's left. So again, we're going to balance that equation out. So we bring down our equal and plus signs. So we have 230 is equal to 4 plus 0 plus x. What would x have to be equal to? X would have to be equal to 226. And then we have our atomic number, so that would be 90 is equal to 2 plus 0 plus x. So what would x have to be? It would have to be 88. And which element is element number 88? We see element 88 comes out to be Ra. So again, we take our Ra, our 22688 Ra, and we move it down here. And that's really it for solving the equations. And you keep going and going and going until you get to your stable molecule. Now, the stable molecule you should get, I'm going to show you in just a moment. So I'm just going to give you a moment to pause the video, and then you can try these out for yourself. So you're going to see if you get to that stable mark. So go ahead and pause the video, keep working on this, and then I will show you what to do. Okay, so at this point, you should have already paused the video. You should have gone to the stable molecule. So let me show you what you should have gotten. If you made no mistakes whatsoever, you should have gotten your stable molecule as, trying to zoom in, as lead 206 over 82. So 206 over 82 pp. If you had any issues with that, here is my key. This is actually how I solved the remainder of the problem. So if you didn't get to 206.82, I recommend just take a look at my key, take a look at how I did this, and then you'll see if you made a mistake on one of your steps. Because mistakes can be common if you do something over and over and over and over and over again. It happens. So now for the graph. Okay, so for the graph part, the values that you're graphing is the elements and specifically their atomic mass and their atomic number. That's kind of what you're graphing here. And let me show you the directions to the graph. The directions say, hold the paper lengthwise. It just means hold the paper normally. Title the graph, which you could just title as atomic number versus mass number. Label the axis. Just as a friendly reminder, your y-axis is the one that goes up and down. Your x-axis is the one that goes side to side. Your y-axis is going to be your mass number. It's going from 206 to 238. So you're going to start with number 206, and it's just going to be 206. Oh, sorry about that. 208, 210, and so on. Your x-axis is going to be going from numbers 82 to 92, skipping every other line. So that would be like 82, 83, 84, and so on. When you directly connect your lines, you're going to use the following color schemes. So when you use the color schemes, I think the easiest way would just be for the color of the element that's going through a certain decay, you're going to put the dot as that color. And you can just connect the dots with like a black line. You don't have to make this overly complicated. So for example, the first answer, if we take a look at that, for uranium, the uranium is going through an alpha decay. So if when you plot this 238.92 dot, you would make the dot red. On the other hand, for this TH, the 234 over 90 TH, when you plot those two dots, you see it's going through a beta decay. So you're going to make this dot blue. Now, For the graphing, you can either print out this plot that I provided you on the Google Meet and then draw it by hand, or you can draw it on the iPad. If you choose to draw on the iPad, I do recommend that you just take a screenshot of it and edit in your photos, because I know Google Classroom, if you zoom in and zoom out too much, that the system can sometimes crash and you could lose all your data, and I don't want you to go through that. So that's one of your options you could do, but again, if you prefer to print it and then draw it out on paper, that's totally fine too. Either way, it's a win-win as long as you get that graph done. And let's go through the conclusion questions, and then I'll kind of give you an idea of what that graph should look like. Actually, you know what? I'll do that now. And this is for 238.92 uranium. Okay, 238.92 uranium decay graph. So this is what your graph should look like. It's going to look like a very weird thunderbolt. So just keep that in mind. You're going to have a weird thunderbolt shape. So if your graph looks like this by the time you're done, you're doing good. All right. Anyway, so let's get into those questions. Question 1. What happens to the mass of a radioisotope when an alpha particle is released? So what that means is what is happening to your final answer. So if I take a look at the final answer, oh, I did not mean to mark that up. So if I take a look at the final answer from before with an alpha decay, we see that the mass goes from By the way, I apologize. My cat is behind me. You might hear him meow, so I apologize for that already. So you can see that the mass goes from 238 to 234. So we can see that mass is decreasing. So our first answer for question number 1 is the mass decreases. If we look at our other thing, the beta particle, we see that the beta particle is going from 234 to 234. So what's happening? In this case, the mass is remaining the same. So again, for number 2, the mass remains the same. Okay. Question number 3 is asking, what happens to the number of protons, or your atomic number, when an alpha particle is released? So let's take a look. We see that our atomic number is going from 92 to 90. So what's happening? It's decreasing. So again, we're going to write down that the number of protons decreases. And now let's look at the beta particle. We see that for the beta reaction, the atomic number is going from 90 to 91. So as a result, for a beta reaction, the number of protons increases. So again, for number 4, the number of protons increases. Alrighty, Spencer, I hope this helped a little bit. But if you have any questions, please feel free to message me on Remind or send me an email at any time. And I hope you have a wonderful weekend. Bye.